Welcome to my video tutorials. Current and previous examples are dedicated to alternating current circuits. In first example, we analyzed and calculated circuit which includes resistor. In the second example, the circuit included one more element, inductor. In the third example was added one more element, capacitor. It was serial RLC circuit. And now we will talk about parallel RLC circuit. So let's get started. As you can see, in this example we have four currents. First current which goes from the voltage source, second current which goes through the resistor branch, second current which goes through the inductor branch, and the last current which goes through the capacitor branch. What do we know? All elements' values, RMS input voltage amplitude, and frequency of oscillations. And at first, let's find all currents. Taking into account that we are considering the parallel connection of elements, so we will talk about conductivities. First of all, let's find active conductivity, then reactive conductivities, and then circuit admittance. Do not forget that conductivity unit is Siemens. Okay, we found all conductivities and we know the voltage which is connected to all parallel elements. So we may find the currents by Ohm's law. Thus, we found all currents, their RMS values. Active current is the current of resistor, and reactive current is the difference between two currents, current of inductor and current of capacitor. And phase shift is 34 degrees. All this data we will use for vector diagram. Next, we will find all powers, active power, reactive powers, and total power of the circuit. Then we will conclude with power balance to prove that we made all calculations properly. As you can see, we obtained the relative error less than 5%. It means we calculated everything properly. And the last, we need to build the vector diagram. Let's do that. This time, taking into account that we have a parallel connection of elements, we will use the voltage vector as initial vector, because this voltage is the voltage of each load of the circuit. Resistor current has the same phase shift as input voltage. Inductor current has the phase shift of minus 90 degrees, and the capacitor current has the phase shift of plus 90 degrees. The total input current vector can be found by the first Kirchhoff's law, which says that current which goes to the node is the sum of all currents which go out of the node. In considered example, the value of capacitive current is higher than inductive current. It means the circuit has capacitive character. It could be such situation when inductive current has higher value than capacitive current. So it tells us about inductive character of the circuit. What will be in case when capacitive current has the same value as inductive current? Watch in the following tutorials. Thanks for your attention.